Rosetta has transformed our understanding of cometary science. It was the first mission to orbit a comet, the first to land on a comet. And since its arrival at Comet 67P on the 6th of August 2014, Rosetta's 21 instruments, 11 on the orbiter, 10 on the lander, have been busy. They've sniffed gases, collected particles, examined the comet across the electromagnetic spectrum, seen how it interacted with the solar wind, and scrutinised the comet's activity as it approached and moved away from the Sun, an unprecedented achievement. The ALICE instrument has been studying the ultraviolet spectrum of the comet, determining what the coma, the gas around the comet, is made from, as well as observing the surface.
We've noticed that there is not ice on the surface. We would be able to see that, at least not large patches of ice. You don't have skating rinks on this comet. And we also see gas in the coma. We see evidence of carbon monoxide and carbon dioxide and the elements themselves of carbon and oxygen in different parts of the coma.
We had considered comets as dirty snowballs covered in patches of ice. But Rosetta has meant we have had to rethink this picture due to a lack of strong evidence for ice on the comet's surface. Instead, the ice is buried beneath the surface, covered by a layer of dust. This dust layer means that the comet is very dark, only reflecting a few % of the light that falls on it. The VIRTIS instrument revealed how water is transported from within the comet to its surface via sublimation, where water changes from ice to a gas without going through a liquid phase. This process provides a frost layer, which is replenished each comet rotation. The OSIRIS camera and VIRTIS have also found more persistent ice deposits on the surface in regions near cliff-like structures. Although other comets have shown a variety of shapes, no one could have predicted that Comet 67P Churyumov-Gerasimenko would resemble a rubber duck. It is also highly porous, and pits containing walls hundreds of meters high revealed layers that helped scientists determine that the comet was formed by a slow collision between two smaller comets. It has no magnetic field, and gases detected include molecular oxygen, hydrogen sulfide, and for the first time found on a comet, argon. The Rosetta instrument revealed that comets like 67P may not have been a dominant source of water for our planet in the early solar system, because its water has a different isotopic ratio. But organic molecules discovered at the comet, such as the amino acid glycine, do tell us that comets could have played a role for the emergence of life on Earth. All of these measurements and more provide an enormous amount of data, allowing a comprehensive picture of one of the earliest objects in our solar system, billions of years old.
The future legacy of the Rosetta data is what we take care of, ensuring that when the mission ends, that this data will be available for the future scientists in the world who want to see what Rosetta did.
Although the mission ends, the data obtained by Rosetta will provide enough work to keep scientists busy for decades.